Hello and welcome. This outcome is about solving radical equations. Given a radical equation, the student will solve it correctly and identify extraneous solutions. So I have those examples for you that I'm going to tackle on the next screen. Well, actually, on this screen, I want to outline the steps that you need to use to solve radical equations. And the first step is you must isolate the radical expression first on one side. The second step, so the first step, isolate. The second step, you must, if you have more than one radical, put the one on each side. Don't keep two radicals on the same side. Then square both sides if you're dealing with square roots, or cube if you're dealing with cube roots. Solve the resulting equation, and if you have square root on each side, you may need to isolate it one more time to do the process, and then check for extraneous solutions. So let's look at these examples. So I have a square root radical equation that's a square root. To get rid of the square root, to make it solvable, I would square both sides. So when I square this side, I'm just going to get what's under the radical, because you're going to square what's under the radical and take square root. So you're doing inverse operations here. And 4 times 4 is 16. And then to solve it, you subtract 7 from both sides. Negative 3, t equals what, 9? Divide by negative 3, t equals negative 3. However, I'm not sure if this is a solution or not, because sometimes when you square both sides, you get extraneous solutions. Let's look at why this happens. Let's say your original equation is x equals 2. And so I'm going to take that equation and square both sides. If you square both sides, you got x squared equals 4. And I'm going to call this a resulting equation. Now, if you want to solve the resulting equation, which you need to, so you're going to, this is a second degree equation. Let's put everything on one side and factor, like as you know. X squared minus 4 factors to x plus 2 times x minus 2 as a difference of squares. So your solutions would be x equals negative 2 or x equals 2. Notice that the original equation is x equals 2. So this is a solution to the original equation. However, this one is not a solution to the original equation. It's only a solution to the resulting equation after squaring. And so x equals negative 2 is called an extraneous solution. So we have to be careful every time we square both sides. We must check for extraneous solutions. So here we need to check negative 3. Negative 3 times negative 3, that's negative 3t plus 7 under the square root. Does that equal to 4? Negative 3 times negative 3 is 9 plus 7. Does that equal to 4? Square root of 9 plus 7 is square root of 16. Does that equal to 4? And yes, it does. So that checks. So that is the solution. If we look at this second example, we have a square root equaling to a negative number. There's no need to really square both sides and solve it, because if you square both sides and solve it, your solutions will be extraneous. However, there's no need to do that, because this is a false statement to start with. The square root cannot be a negative number. I mean, it's the principal root. It can't be a negative number. Whenever you deal with a false statement, there'll be no solution, or the solution is the empty set. Let's do more examples. Okay, here I have 2 square roots, and those square roots could have been on one side of the equation. If they were on one side of the equation, you must put them on 2 sides, like here. I already put them on two sides of the equation. Now I'm going to square both sides. So when you square a radical, you just get what's under the radical. When you square this side, you're going to distribute this power because you're squaring a product, multiplication, 2 times the square root. You're going to square the 2, you get a 4, and then what's under the radical is 5x minus 9. Now, to solve this equation, you've got to distribute 3x plus 5 equals 20x minus what, 36? And now let's put the x on one side. Let's subtract 20x from both sides. So we have negative 17x plus 5 equals negative 36. Let's put the 5, get rid of the 5, subtract 5 from both sides. We have negative 17x equals negative 41, divide by negative 17. So x equals 41 over 17. And I would like you to check if this is, check your solution if it's a solution of it's extraneous. Let's do this one. Here I have a square root and something else which is a plus 6 on one side. So I need to isolate the radical. Remember from the steps that we've talked about, the first step is to isolate the radical. So I leave the 18 minus x on one side, square root of 18 minus x on one side, and so the other side becomes x minus 6. Now that I isolated the radical, I'm going to square both sides, square this side and square this side. When you square this side, you get what's under the radical. When you square this side, you are multiplying x minus 6 by itself. So you're actually multiplying a binomial by a binomial, or squaring a binomial, which you need to FOIL. Once you FOIL, you get x squared minus 6 inside, minus 6x outside is minus 12x plus 36. And so we have 18 minus x on this side. Let's, since it's a second degree quadratic equation, we're going to put everything on one side. So I'm leaving this side here, and I'm subtracting 18 and adding x. So I can have this side 0, because I'm going to solve the quadratic equation by factoring. Let's combine like terms. Negative 12x plus x is negative 11x. And then 36 minus 18 is plus 18 equals 0. And let's see how we can factor this. X squared is x times x, 18. Let's try 9 and 2. And let's do negative 9 and negative 2, which will work. Gives you negative 11 for the middle term. So that's going to give you x equals 2 or x equals 9 when you solve that. So you really need to check this back in the original equation to make sure it works. And so let's see. If I try 2, the square root of 18 minus 2 plus 6, does that equal to 2? 18 minus 2 is 16. So the square root of 16 is 4 plus 6 is 10. Does 10 equal 2? No, it does not. So I know this is extraneous. So I have checked this before I did this one. So 9 works and 2 doesn't work, but you need to verify that to make sure. This example is about a cube root, solving a cube root. When you have a cube root, again, you're going to cube both sides, and you don't really worry about extraneous solutions because the cube root have no restrictions whether you get positive or negative values for it. So 2x minus 3 equals negative 125. That's negative 5 times negative 5 times negative 5. And then add 3 to both sides. So you got 2x equals negative 123. Divide by 2. I think I'm writing faster than it takes it. So that's negative 123 over 2. And that would be the solution. No need to check for extraneous solutions. I think that's it. See you next time.